Okay, the third page of these notes. So we talked about these, the effect last time of the amplitude and period, basically making it taller or more stretched out. So now what we should learn in this section is what translations do, moving it up, down, left, right, whatever. And I think it's mostly just doing the left and right stuff. So here we go. The constant c in this general equation, so this is the general equation. So this one creates the c, so we're just talking about the c. It's going to be a horizontal translation, which we know is a shift of the basic sine and cosine function curves. So if we were to compare this graph, so basically a curve or a y equals without the c and with the c, this one completes one cycle. So if we're looking at this thing, it completes one cycle from bx minus c equals 0. So from when this part equals 0. And then it's also going to complete one cycle as long as the period's normal, which b would tell us the period. So between bx minus c equals 2 pi, because those are the two places where the sine graph equals 0. So when we have 0 and when it's 2 pi, because it goes up, down, back up. Yeah, up, zoom, like that. That's when it completes it. And then this implies that the graph of this thing is shifted by the amount. Oh, wait. Okay, well, we don't have that line in here. Okay, by solving for x, you can find the interval for one cycle to be, we just talked about this, from c divided by b. That was one cycle or one period. And then it's going to go to c divided by b plus 2 pi divided by b, which means that the amount shifted by is going to be c divided by b. And then the period of the graph is shifted by the amount of 2 pi b. So basically it's saying that it moves it to the left or moves it to the right. And this is all the fancy mathy way of saying it, which is great, but it makes more sense once you're getting into the problems. So here's an example and how we can get into it. So we don't even have to graph this to be able to answer the questions. So it wants us to find the amplitude, period, and then they call the shift, the phase shift. So phase shift, instead of just a shift, it's called a phase shift. So we know that this is the amplitude. We know that the number in front of there is the b, which it equals 1, so that's nice. And then that this number right here is going to tell us our phase shift. Phase shift. So our amplitude is 2. Our period is 2 pi divided by 1, which is just 2 pi. And then our phase shift is going to be, so the opposite of minus pi fourths is positive pi fourths. And the reason why it's the opposite is because up here, we would set that equal to 0, and then we would move pi fourths over to the other side, making this minus pi fourths become positive pi fourths. Okay. Example 6, find the 6 key points of that graph. So it's going to go like this. So I prefer drawing it because I'm more visual. So I know it's going to go up to 2, down to 2, and that the phase shift was the normal, the normal period is 2 pi, but it's shifting it to the right by pi fourths. So normally it would start at 0 and end at 2 pi. But instead it's going to go to the right pi fourths. So if I do the normal graph thing, because I like to, I'd have pi halves, 3 pi halves. So this would be for a normal sine graph. But it's shifting everything to the right. So instead of starting here, it's going to start halfway between those at pi fourths. And then it's going to shift everything by pi fourths. So if you look at your unit circle, which do I have that with me? If you look at your unit circle, then pi fourths after this one. So if you're looking and thinking about your unit circle, here's our unit circle. We know that this is pi, and we're just talking about these fourths, right? We know that these are the odd numbers, so pi fourths. So 1, 3 pi fourths, 5 pi fourths, and 7 pi fourths. If we kept on going, that would be 9 pi fourths, 11 pi fourths, and so on. So we have pi fourths. So what's one of those little things after pi? Oh, that one right here is 5 pi fourths. And another another fourth pi after this is going to be, so if that was 7 pi fourths, this over here will be 9 pi fourths. Right, did we get them all? We need this one right here too. Right, yep. 3 pi fourths. 1, 3, 5, and so we need the one in between there. 7 pi fourths. So they're just going by odds. So pi fourths. So we're basically going pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths, and back up to 9 pi fourths. So the red was the original, and everything else we just added pi fourths onto it by using our unit circle to make it easier for us. And then the graph is going to start, instead of starting at 0, it's going to start here. It's going to go up to 2 at 3 pi fourths. Because it goes up, down, up, right? So the sign is always starting down here, going up. Then it's going to cross right here. Then it's going to be its minimum down there. And then cross again right there. So it's going to do this curvy thing. So then the 5 points. I like to see the graph. It makes more sense to me. If that didn't make sense to you, I can show it a different way when I get back. So let's see. We want the intercepts. Somebody's making noise on my front porch. Sorry. Okay, so the intercepts. We have one at pi fourths. 0. I'm going to do that. So that's one intercept. Looking at here, I can see the other one is at 5 pi fourths and 0. And the last one is at 9 pi fourths, 0. So those are our intercepts. Then we have our max is up here at 3 pi fourths, 2, positive 2, and our min is at 7 pi fourths, negative 2. So those are our 5 points. Okay, and then a real life situation that could be modeled by a sine or cosine function. There are so many. So one of them is sound. Sound travels in waves. The ocean has waves, or some of the big seas. Other things you can say is like this: if you were to look at a graph of the sun, basically it goes up and down and up and down and up and down and up and down, and it's going to be different. So anything that you can think of that goes up and down and up and down, you could say classes, like you go and you come and then you come back home, and then you leave and then you come back home. So there's lots of examples. For this last problem, part of the thing, It says, what trigonometric function would match this following table? So for the sake of speed and time, I just made the graph, and I'm graphing them. So it starts at 0, it's at 2. At pi halves, it's at 4. At pi, it's down to 2. At 3 pi halves, it's at 0. And at pi, 2 pi, it's back to 2. So to me, this looks like something that we didn't necessarily go over. Did they have that in this lesson? Let me just double check here. I don't know if they did. 89, and this is 90. Okay, this is just talking about, to me, it looks like that's that center line right there. And it's got the normal period. So that would be the center line. So it looks like the amplitude is 2, because it's going up 2 from that center line and down 2 from that center line. But it's got the normal period because it starts and stops in 2 pi. It starts on the down instead of up. So I'm going to say it's sine. And I know the 2 goes in front because it's going up and down 2. So 2 sine of x. But then the whole thing was shifted up. So notice it's not in the parentheses, up by 2. So I would say this fits that. And for the homework. And the homework is 5 through 79, every other odd. So they call that EEO. In future reference, we'll call that EOO, EOO, every other odd. And then these problems. So that's a lot, which is going to be, you can do it. I know you can. So the rest of the time in viewers in class is to work on that. Please work on it tonight so that when I come back tomorrow, you'll have good questions and that we're not just starting from scratch again. So it's 4.5. I don't remember what page it starts on. I don't have the book with me, but it's 4.5, numbers 5 through 79, every other odd, 93, 95, 96, and 102. Notice there are 2 even problems. Okay, you can do it.